Alrighty, all today we're taking a look at question 5 for recitation 23. And for this one, we're trying to find the magnitude of the net force on the rectangular loop. Alright, so we have a long wire here with a current 15 amps, and then the loop, we have our current of 30 amps, right? And we have the dimensions of everything as well. Alright, so I'm going to start with breaking it into different sections because I only know how to find the force between two wires. I don't know a wire in a loop. So I'm going to cut it at each of the corners and do each line separately. All right, so I'm going to start with this one. We're going to call this A, call this one B, and C and D, all right? So we have a current going this way, current going this way, current going this way, all right? So let's start with A. All right, so our magnitude of our force, all right, our force is our mu naught I1, I2, L over 2 pi r, right? Our r is our distance between them, and our L is the length of our shorter wire here, right? And we have our I1 and I2. Again, doesn't matter which one's which because, right, it doesn't, flipping the order of multiplication doesn't change anything. All right, so our first wire, wire A, right, is going to be our FA. This will be our mu naught. Actually, I'm going to simplify this again because our mu naught, 4 pi times 10 to the negative 7th. If we're dividing by 2 pi, that's just our mu naught's going to turn into our new coefficient. 2 times 10 to the negative 7th because that pi is going to cancel out and the 2 is going to cancel out. Our I1, I'm just going to call that the 15 amps. Again, it doesn't matter. I2, 30 amps, and the length of our wire is 30 centimeters, but again, always in base units, 0.3 meters. Okay, because that's the length of both sides as well. Right, oh, I should write that in units in the equation, right? And that's all divided by our radius, our distance between the two wires, which is our 7.5 centimeters or 0.075 meters. Again, always in base units, right? And that's going to give you some FA, right? Now we're going to do the same thing for B, right? FB is our same thing. Constant's going to kind of cancel to that. I1 hasn't changed. I2 hasn't changed. And our length is still the same as well, 0.3. Right? The difference for this one, for FB, is going to be our radius, our distance between the two wires. So we're going to go here to here instead. So that's going to be 7.5 centimeters plus 10 centimeters. Again, if that's going to be 17.5 centimeters, but convert all that jazz into meters, it's going to give us 0.175 meters. And so that's what we're going to use down here, 0.175 meters. Right? And that's going to give you some value for FB. But the difference is, right, our current in this one is going to the right. Right? Our current in this one's going to the left. Right? So what that's going to give us, this is just getting our magnitude of the forces. But since these are going in opposite directions, like it's a positive current and a negative current, positive current and negative current, so our FA is actually going to be negative, whatever we solve for. Right? And then this is going to the right, this is going to the right, so this is a positive and positive. That's going to be a positive. We're going to call that our positive direction for right now. Right? Which is important because I don't want to integrate over a radius because that's like a pain, right? Because for this, our force, our magnetic field is dependent on the radius. And for these two side pieces, the radius is changing because the radius, like here, 7.5. The radius out here is our 17.5 centimeters, right? So our radius is changing throughout this, which means our magnetic field is changing, which means our force is changing over all of this, and I don't want to integrate. But since this is going down and this is going up, they're going in opposite directions. Everything else about them is the same. right? They're both going between the same two radii. They have the same current, all this stuff. They have the same length, all this. They're just going to cancel out. So our force from C and our force from D is just going to equal 0. So when we go to add everything, our total force is going to equal our force B minus our force A, right? And this might spit out a negative value. Actually, I think it should spit out a negative value. But since the question is just asking for the magnitude, you can just take the absolute value of that as your answer. And that should give you your answer in newtons, right? Because base units. All right, well, I hope you found this video at least a little bit helpful. Let me know if you have any more questions about this problem or any other problem that you want me to try to explain, and I will do my best to explain it because I guess Sydney explains stuff.